everyone, let's start today's class. So today at first we are going to solve this numerical. So since this is the first numerical, I am going to solve it in detail, but from the next numerical I shall do it in shortcut. So here the Lagrange's auxiliary equations are dx by x equal to dy by y equal to dz by z. Now we are going to mark it number 1. So from first two ratios of equation number 1, what we get? We have dx by x equal to dy by y. Now on integration, we get log x equal to log y plus log c1, where c1 is an arbitrary, constant. Or log x minus log y equal to log c1. Now we are going to remove the log part. Again, from the last two ratios, you can also choose the first and last ratio of equation number 1. We have dy by y equal to dz by z. Now on integration, in exam you have to write in this way only, plus log c2, where c2 is an arbitrary constant. Or log y minus log z equal to log c2. Again here also we are going to remove the log part. So what is the general solution? Phi of x by y comma y by z equal to 0, where phi is an arbitrary function. You can choose here f also or any other function. Now we are going to solve this numerical. So here the Lagrange's subsidiary or auxiliary equation is dx by 1 equal to dy by 1 equal to dz by sin x. Now choosing the first two ratios, what we can write? X equal to y plus c1 or x minus y equal to c1. And we are going to choose first and third ratio. So dx equal to dz by sin x or sin x dx equal to dz. Now we are going to integrate it, or minus cos x equal to z minus c2, or cos x plus z equal to c2. So the general solution is phi of x minus y comma cos x plus z equal to 0. Now we are going to solve it. Here the Lagrange's subsidiary equation is dx by y squared equal to dy by minus xy. Always remember, if there is minus sign, we have to write it. So now we are going to choose the first two ratios. what we get? Dx by y equal to dy by minus x, or minus x dx equal to y dy, or what we are going to get? If we put this there, x squared plus y squared, we are removing the 2 from the first only, equal to c1, and we are going to choose the last two ratios. Dy by minus y equal to dz by x into z minus 2y, or here here we are going to cut the x because we are removing x from both. So z dy minus 2y dy plus y dz equal to 0, or d of yz minus 2y dy equal to 0, or yz minus y square equal to c2. So the general solution is, yes, phi of x square plus y square comma yz minus y square equal to 0. Now we are going to solve this numerical. So here the Lagrange subsidiary equation is dx by x square equal to dy by y square equal to dz by minus z square. So at first we are going to choose the first two ratios. Dx by x square equal to dy by y square. Now integrating, what we get? Minus 1 by x equal to minus 1 by y minus c1, or 1 by y minus 1 by x minus 1 by y equal to c1. Now we are going to choose the last two ratios. So dy by y square equal to dz by minus z square, or minus 1 by y equal to 1 by z minus c2, or 1 by y plus 1 by z equal to c2. So the general solution is going to be phi of 1 by x minus 1 by y comma 1 by y plus 1 by z equal to 0. Now we are going to solve this numerical. So here the Lagrange's auxiliary equation is dx by 1 equal to dy by minus 2 equal to dz by 3x squared sine of y plus 2x. Now we are going to choose the first two ratios, or minus 2 dx equal to dy, or minus 2x equal to y minus c1, or c1 equal to, or you can write 2x plus y equal to c1. Now we are going to choose the first and third ratio, that is dx equal to dz by 3x squared sine of y plus 2x. Now in the place of y plus 2x we can put, yes, c1. So 3x squared sine c1 dx equal to dz, or integrating, what we get? Sine c1 is constant and this will be x cube equal to z plus c2, or x cube sine of 2x plus y minus z equal to c2. That is, the general solution will be phi of 2x plus y comma x cube into sine of 2x plus y equal to 0. Now we are going to solve this numerical. So we know that del z del x equal to, yes, p, and del z del y equal to q. So here the Lagrange's subsidiary equation is dx by x minus a equal to dy by y minus b equal to dz by z minus c. Now choosing the first two ratios, what we get? We get dx by x minus a equal to dy by y minus b. And integrating and removing the log, what we get? X minus a by y minus b equal to c1. And choosing the last two ratios, what we get? Dy by y minus b equal to dz by z minus c, or y minus b by z minus c equal to c2. So the general solution is y by b by z minus c equal to 0. Now for solving this numerical, at first we have to expand it. So this is equal to z cube plus xyz into px minus y q into y equal to x to the power 4, or px z cube plus px squared yz minus qy z cube minus qx y squared z equal to x to the power 4, or p into what we are getting, xz cube plus x squared yz. So here we can choose x and z as common. So within bracket what we are left with? Z squared plus x y into p minus q y z into z squared plus x y equal to x to the power 4. So what is the Lagrange subsidiary equation? Dx by xz into z squared plus xy equal to dy by minus yz. It is better to write q here. Z squared plus xy equal to dz by x to the power 4. Now choosing the first two ratios, what we get? Dx by x into z squared plus xy equal to dy by minus y z square plus xy, z square plus xy also cut each other. So what we are left with? Dx by x equal to or plus dy by y equal to 0, or log x plus log y equal to log c1, that is xy equal to c1. Now we are going to choose first and third ratio. So what we get? Dx by z into z square plus xy equal to dz by x cube, or dx by z into z square plus c1 equal to dz by x cube, or x cube dx minus z cube dz minus z c1 dz equal to 0, or x to the power 4 by 4 minus z to the power 4 by 4 minus z square by 2 c1 equal to 1 by 4 c2, or x square minus z square minus 2 z square xy, that is we are going to put the value of c1 here, equal to c2. So what is the general solution? Yes, phi of xy comma x to the power 4 minus z to the power 4 minus 2z squared xy equal to 0. Now we are going to solve this numerical. So here the Lagrange's auxiliary equation is dx by s1 equal to dy by minus y log y equal to dz by, yes, z log y. Now choosing the last two ratios, what we get? Dy by minus y equal to, yes, dz by z, or this is log y plus log z equal to log c1, or yz equal to c1. Now we are going to choose the first two ratios. So what we get? Dx equal to dy by minus y log y, or minus dx equal to dy by y log y. Integrating, what we get? Minus x equal to, yes, log of log y minus c2, or log of log y plus x equal to c2. So what is the general solution? Phi of yz comma log of log y plus x equal to 0. Now we are going to solve this numerical. Here the Lagrange's auxiliary equation is dx by y equal to dy by x equal to dz by xy z square into x square minus y square. Now choosing these two ratios, what we get? X dx minus y dy equal to 0, or x square minus y square equal to 0. Now we are going to choose the last two ratios. So dy by x, or you can directly write dy equal to dz by yz square x square minus y square, or y, this is it, sorry, here it will be c1. So y c1 dy equal to dz by z square, or integrating, what we get? c1 y square by 2 equal to minus 1 by z plus c2, or c1 y square by 2 plus 1 by z, and what is the value of c1? X square minus y square equal to c2. So what will be the general solution? Yes, phi of x square minus y square comma x square minus y square into y square by 2 plus 1 by z equal to 0. Now we are going to solve this numerical. So here this is equal to actually y squared z into p plus x squared z into q equal to x y square. So what will be the Lagrange's subsidiary equation? Yes, dx by y square z equal to dy by z square, sorry, x square z y square. Now from the first two ratios, what we get? Dx by y square equal to dy by x square, or x square dx minus y square dy equal to 0, or x cube minus y cube equal to c1. And from the first and third ratio, what we get? Dx by z equal to dz by x, or x dx minus z dz equal to 0, or x square minus z square equal to c2. So what will be the general equation or general solution? It will be phi of x cube minus y cube comma x square minus z square equal to 0. Here the Lagrange's subsidiary equation is dx by xy squared equal to dy by minus y cube equal to dz by, yes, minus axz. Now from the first two ratios we get or xy equal to c1, and from the second and third ratio what we get, dy by y cube equal to dz by axz, or dy by y to the power 4 equal to dz by axyz, or dy by y to the power 4 equal to dz by ac1 into z, or it is going to be, this is y to the power minus 4. So 3 by y cube equal to, or you can shift the AC1 here. So AC1 dy by y to the power 4 equal to dz by z, or AC1, this is y to the power minus 4, so it will be minus 3 by y to the power 3 equal to, this is log z, plus c2 or minus c2. So 3a, c1 means xy, x by y square plus log z equal to c2. So what will be the general solution? Phi of xy, you can also write in this form, phi of xy equal to 3ax by y square plus log z. Sorry, here it will be minus 1 by 3. Now we are going to solve this numerical. So here the Lagrange's subsidiary equation is dx by z equal to dy by minus z equal to dz by z square plus x plus y whole square. Now choosing the first two ratios, what we get? Dx by 1 equal to dy by minus 1, or x plus y equal to c1. Now we are going to choose the first and third ratio. What do we get? Dx by z equal to dz by z square plus x plus y whole square. Z dz by z square plus, we can put here, yes, c1 square, or integrating what we get? X equal to half log of z square plus c1 square minus c2, or x minus half log of z square plus x plus y whole square equal to c2. Sorry, this minus x equal to c2. So what is the general solution? Phi of x plus y comma half log of z square plus x plus y whole square minus x equal to 0. So that's it for today. We are going to meet in the next class. Till then, bye.